Given an arbitrary set A, how many different subsets can be formed out of A? You might suspect that the answer to this question will depend on the number of elements in the set A. So let's try a few simple toy examples to see if we can get a general pattern. Let's start with the simplest set, the empty set. How many different subsets can the empty set have? It can have only one subset, which is the empty set itself. So the number of subsets that the empty set can have is just 1. Now let's move to a set with one element, a singleton set. So let me write here that we are talking about a set of size 0 over here, a set of size 1 over here. So how many subsets can a singleton set have? It's going to have the empty set as a subset, because the empty set is a subset of every set, as we've seen earlier. And the other subset that it can have is the singleton set itself. So it can have two different subsets. So when the number of elements is 0, the number of subsets are 1. When the number of elements in the set are 1, the number of subsets that it can have is 2. Let's take a set with 2 elements now. How many subsets can be formed out of this set? As always, the empty set will be a subset of this set. So the empty set is a subset of size 0. How many subsets of size 1 can be formed out of this? Well, we can just take both of these elements individually and form singleton subsets out of them. So this is a subset of size 0. These are the two subsets of size 1. And finally we can form a subset of size 2, which is the set itself. This is a subset of size 2. So these are the 4 different subsets that can be formed out of this 2-element set. So the total number of subsets that can be formed is 4, which I'll just write as 2 square. So let me write this 1 as 2 to the power 0, this 2 as 2 to the power 1, this 4 as 2 to the power 2. Now let's go to a set of size 3. How many subsets can be formed out of it? The empty set, as always, will be a subset, the only subset of size 0. How many subsets of size 1 can be formed out of it? We can take the 3 elements individually and create 3 singleton subsets, each of which has a size of 1. How many subsets of size 2 can be formed out of this 3-element set? Well, we can take 2 elements out of these 3, 2 at a time. So we can take 0 and 1, or we could have taken 1 and 2, or we could have taken 0 and 2. So these are the 3 subsets of size 2. How many subsets of size 3 can be formed? Just 1, which would be the set itself. So this is the only subset of size 3. So the total number of subsets that can be formed out of this set is 1, 2, 3, 4, 5, 6, 7, 8. So 8 subsets can be formed, and I'll just denote the number 8 by 2 to the power 3. So you can see a pattern forming over here. When the number of elements is 0, the total number of possible subsets is 2 to the power 0. When the number of elements is 1, the total number of subsets is 2 to the power 1. When the number of elements is 2, the total number of subsets is 2 to the power 2. When the number of elements is 3, the total number of subsets is 2 to the power 3. So you can guess that when the number of elements is m, the total number of subsets are going to be 2 to the power m. And this guess would be correct. It can be formally proven using techniques like mathematical induction or a simple combinatorial argument, which we will both of which we will look at in later chapters. I will leave that as a simple exercise for you here, and if you're not able to solve it right now, I'm sure you'll be able to solve it after we cover the chapter on mathematical induction and combinatorics.